Um, Hello guys, once again. So, this is the last subsection or the last section under chapter 1. After we are done with it, I think you all will be ready. You just have to do a lot of practice, and yeah, maybe I will find I'll make another video which will be the last video where I'll just taking all the problems from all the subsections in this topic, and yeah, we'll see, we'll just have more fun solving these problems. All right, so let's get to it. Fortunately, with this video, guys, I want to apologize for the previous ones. There was a guy in the background cutting grass, and I did hear that there was, yeah, the videos they messed up. So I hope that you will be able to hear everything. Yeah, I apologize for that. Could have chosen a better time. Cool stuff. The first question is very interesting in that I'll go to what I've been saying with other problems, and that you can do it in many ways, which will lead you to the right answer. Right. So I'll say maybe the first person. First person can say, okay, there I say they added what? The exponents. I have a sum of my exponents. What does that mean? It means that there was a multiplication of the same basis, which is 2, which led us to adding our exponents. So basically I had 2 to the power of x multiplied by 2, right? Cool. And now they say, okay, let me take this 32, take it to that side. So I have what? Now I have 32. Divide this by 2, divide by 2, you have 2 to the x is equals to 16. Now when we are solving x, what we're going to do is we try to have either the same exponent or the same basis. So here we know nothing about the exponents. We can work with the basis. Fortunately, 16, we can write it as base 2, and that is 2 to the power 4, I believe. Yes, it's 2 to the power 4. Cool. Now you have the same basis. What does that mean? Your exponent must be the same. Therefore, x is equals to 4, and then you're done, right? Now the second person can be like, okay, cool, I have 2 to the power of x plus 1 is equals to 32, right? Now next step, 2x plus 1, and then this is 2 to the power of 5, and then what? I have the same basis. That means my exponent has to be the same, so that means I'll have x plus 1 is equals to 5, and we do the maths, transpose 1, you have 5 minus 1, and your x is equals to 4. Same answer as before, right? So it doesn't really matter, so long as you follow the rules and everything. I'm positive you get the right answer. Let's see, let's use blue for number 2. Right, let's use blue. Yeah, I mean, okay, so blue, we can work it out. Multiply x to the power of let me okay, I'm gonna do what I've been doing. I'll say there are 2 people, right? There are 2 people. First person says, okay, firstly let me say let x to the power of 1 over 3 be k, right? So now what do I have? I have k into k plus 1, say minus 6 is equals to 0. That is k squared. K squared, that is plus k minus 6 is equals to 3. And so you guys must know how to factorize, but don't worry if you've forgotten how to factorize. I'll show you like proper method step by step in chapter 2. So with this one, you have your 2 brackets equals to 0, so you're gonna have k minus it's gonna be plus 3 here, and then k minus 2. Right, I will just show you how to do all this in chapter 2. Yeah, so cool. Now in the next step you realize therefore k plus 3 equals to 0, or k minus 2 equals to 0. But remember, you said k is what? Is x to the power of 1 over 3 is equals to, no, plus 3 equals to 0. And then you have x to the power of 1 over 3 minus 2 equals to 0. That means x 1 over 3 is equals to minus 3. X to the power of 1 over 3 is equals to 2. Right? From here, damn. From here, what do? You can just multiply your exponents by 3, right? Then you're gonna have x is equals to 27, negative 27, or 3 to the power of negative 3 to the power of 3, right? And you do the same thing here. You have your x is equals to what? X is equals to 8. That has to be the answer. Yeah, it has to be the answer. Should we verify? Cool, let me see. Let me verify the answer. So it's 2, no, it's 8, so that's 2, 2, 3. Yeah, that will be the answer. That will be the answer. Cool. Now, the second person solving this problem can actually say, multiply that. So they will have, we're going to add the exponents right here. So that will be 2 over 3. Yeah, plus x to the power of 1 over 3. And then, of course, Mimi transpose 6 minus 6 is equals to 0. Right? Of which, here's something interesting. You realize we have x to the power of 1 over 3. What am I doing actually? What am I doing? Okay, we have the same thing as x to the power of 1 over 3 squared, right? Plus 3 minus 6 is equals to 0. Cool. So, yeah, some people may be confused by what is really going on here. But remember, there is that law that says when you raise power to power, you multiply the exponents. Basically, if I have x to the power of n and everything to the power of m, the answer is just x to the power of n m, right? No. N, which is basically what I'm doing right there. I have 2. So I have right here I have 1 over 3, and right here I have 2, which my answer is gonna be x to the power of 1 over 3 multiplied by 2, which is x to the power of 2 over 3, right? So I didn't change anything. And then from here you can say let k be what? Be x to the power of 1 over 3. From there you're just gonna do exactly what we did on the left hand side, and you get to the same answer we had. Right? Cool. If you don't understand, just go back, rewatch the video, rewatch the solution, and yeah. Something very interesting about number 3. Let's do it. Let me use color green. Cool. For number 3, it's very interesting, right? It's very interesting. So the question is, what are we doing here? We are solving for x, right? But of course, in number 3, we are solving for z, right? Number 3, we are solving for z. Cool. So now, what am I saying? We want to solve for z, but there is something that prevents us. I mean, it doesn't prevent us from solving for z, but it sort of makes it difficult for us to find z, right? So, and that problem that I have is this right here. This is the problem that I have, right? So now I'm gonna do something to make the problem easier for me, right? I want to make maths to be very easy, right? Yeah, maths is very nice when it's easy. Jokes. Cool. So for me to eliminate this problem or deal with it, I'll just have to transpose the whole thing to the other side. So I'm gonna have 2z plus 3 equals to 7 root z, right? And now I'm gonna square everything. Remember, laws of equations, what you do on the left you do on the right. So cool. So here I'm gonna have 4z squared And wait, what? I just want to see. Okay, cool. I'm gonna have that plus okay guys, this is one other law as well. You don't have to like expand the whole thing and multiply. I'll show you exactly. Maybe let me start right here. Let me start. First thing, you square your first number, which is 4z squared. Now you multiply the two numbers and you have 6z, right? We take that sign plus. You multiply the numbers inside, that is 6z, and you multiply them by 2, you have what? You have 12z. Cool. Now you square, it's plus, you square the last one, which is going to be 9, and this side we have 14z. Cool. Yeah, I think that's cool. So cool. No, not 14. No, what am I doing? This is 49. Come on. Cool. So now I have 4z squared. I have plus 12z minus what? Minus 49z and plus 9 equals to 0. Cool stuff. So I can just work it out. That's yes. The subtraction there is gonna be minus. That's 737 plus 9. Cool stuff. Cool. So there's a method that I usually do. When we're factorizing, I'm like, focus on the coefficient of the first and the last number. Precisely, if you have a trinomial, focus on the coefficient of the first number and the last number, which in this case is 4 and 9. So multiply the two. 4 multiplied by 9, your answer is 36, I believe. 9, 18, 27, 36. Yeah. And now we're going to try to find factors of 36. And 36 times 1, of course. So when you're doing this, I think this is going to be 18. When you're doing this and pairing these factors up, you want to find a pair that gives you the middle number, whether you'll be subtracting or you'll be adding, right? So there's you multiply the first coefficient and the last one, which is 4 and 9, you get 36. You break down 36 into each factors with pairs, right? 36 times 1 is 36, 2 times 18 is 36. You're gonna do that, right? But you don't have to do it all over. You just have to do it until you find two pairs. Until you find a pair which, if you add the numbers or subtract the numbers, you're going to get the middle number, of which here we have found that pair. It's 36 and 1, right? So what can I do? I can say I have 4z squared. Now what do I have? Let's say I have minus 36z minus z, right? So if I have negative 36 minus 1, the answer is minus 37. That's why right here I just have minus 36z minus z. They are all gonna give me my middle number. So I did not change anything in this problem that I have. And I have to push this one down. Cool. So now we're gonna group these things, right? So the first group is gonna be a 4z squared minus 36. We group it, and then plus another group is negative z plus 9, right, is equals to cool. So now what do? We find the common numbers or common factors in each bracket or in each group. The first one, you have 4z, I believe, so that's 4z, and you have z minus 9. The second one is minus 1, so you have z minus 9. Cool. And then you're gonna have the common factors again. It's z minus 9. Now the remaining numbers, 4z minus 1 is equals to 0. Now you're just done. Z minus 9 is equals to 0, or 4z is minus 1 is equals to 0, which z equals to 9, or for z equals to 1. You have z equals to 1 over 4 or z. So this 2 becomes what? Those 2 becomes a solution. When you are done, you are done. It was quite a problem. So one thing that might be a bit trickier here is the way I factorized. During when I was doing my high school FET grade 10, 11, 12, I realized that the method which I was using, I don't know, I was taught this method by a friend of mine. So it looks like many of my peers didn't use this method, so that's why I'm gonna put much more emphasis in the next chapter when I do factorization. But that is number 3. Now we're gonna do number 4. Right, guys, so number 4 is very interesting. What makes it interesting is that I would say look at number 2. Go back and look at this is number 2. They have, I mean, there's something we're gonna do in number 4 that we did in number 2. So these 2 numbers, they look quite the same, right? So remember, guys, when you are solving a problem, is you are solving a problem. Before you do solve a problem, just check, is there anything that makes it maybe challenging or difficult for me to solve this problem? And then if there is, you try to solve that thing. Once it's solved, then the problem becomes a bit easier to solve than it was before. So cool, that's exactly what I'm gonna do right here. So of course, I mean, I don't know how to put this, but you have your exponents as what, as fractions, right? Which can be very, very confusing. But looking at how we dealt with number 2, I hope that sort of gives you a clue. So I'm just emphasizing, pause the video, try to do this one. If you found it challenging, pause the video one more time, try to do it, try to see if you can find anything, right? But one thing I will say is the more you do these problems, the more it will be easier for you to come up with these ideas, right? So with number 2, let me see, I'm gonna use a purple. Let me use purple. So remember, with the last one, I had x to the power of 2 over 3, and then I eventually plus whatever. Then eventually I was like, this is x 1 over 3 squared, and then eventually I was like, let x to the power of 1 over 3 be k, right? Cool. I can do the same thing right here. And of which the easiest number that just came to my mind is, let's see what will happen if we write this denominator as, if we write this fraction with the denominator 4. We're gonna have 2y 2 over 4, which is half. So we didn't change anything at all. Everything is still the same. 1 over 4 plus 1 equals to 0, right? So now I can do exactly what I did on the previous problem. No, not the previous one, number 2. I can say I have y to the power of 1 over 4 to the power of 2. 3y to the power of 1 over 4 plus 1. Remembering that rule, raising power to power, what do you get? You multiply the exponent. So I know I haven't changed anything at all. Then here I can then say let y to the power of 1 over 4 be k, right? And now I have 2k squared minus 3k plus 1, right? And is equals to 0. So, and guys, I just want to also say, the reason I've been saying let something bk is because I want to make maths very easy. I don't want to make maths to be challenging for me. I don't want to create problems while I have to solve problems. Remember, in maths we're just solving problems, so while you are solving problems you don't want to bring up more problems while you're solving that problem, so basically this is what this k is allowing me to do, right? Cool stuff. So I'm gonna use the same method of factorization I used in the previous example, number 3. So remember, the focus is where? The first coefficient and the last coefficient. Cool stuffs. So let's go. 2 multiplied by 1, the answer is what? Is 1. We read the factors of 2, it's 2 and 1. Fortunately, those are the only factors. But fortunately, these pair of factors, they give us the middle number if we subtract them. So if I have minus 2 minus 1, the answer is minus 3, right? So this is the most fortunate part about this problem. So now I can say, let me erase this part. I can say 2k minus 2k squared minus 2k minus k plus 1 equals to 0. And then I group them. And I take out the common factors, which this side is 2k. Here's minus 1. Grouping common factors again, which is k minus 1, and the remaining under the last bracket. So of which here you have k equals to 1 or 2k equals to 1, right? Which of course you'll just say y to the power of 1 over 4 equals to 1, and 2 y to the power of 1 over 4 equals to 1. Then you just solve, you get your, I don't have space, then you just solve and you get, like, okay, maybe here you can say y equals to 1, but for this one you have to say for example you have y over 4, you divide by 2 both sides, so you'll be having 1 over 2, you multiply by power 4, you raise everything to the power of 4, so y is equals to 1 over I think 16, then you have your answer. Cool, that's the problem. And yeah, I don't have space for the last one, so I'm just gonna copy this into the next page. Yeah. Something very interesting just happened, but cool. So this one, nicely enough, let me use pink. Nicely enough, the numbers are already, I don't have to transpose any number, so I'm just gonna eliminate this problem of the set straight away. I have 31 minus 10d, right? This side I have 4 squared. No, I have 16, and then I multiply this 2, which is minus 4d, and then I multiply that by 2, so which is 8d, and then I'm squaring, so it's positive d squared, right? So I can say I have 0, it's gonna be 16 minus 31, and then minus 8d plus 10d plus d squared. Okay, that's 15. I think the answer here is 15, negative 15. Let me just say I have d squared plus 2d minus 15, right? Cool. So here let's do that same method we were doing. So here you have 1, so 1 multiplied by 15 is what? Is 15. Factors of 15 is 1 and 15 There's no 2, there's 3 and 5. I think that's just it. And now which pair gives us the middle number, whether we add or subtract? It's this pair right here, right? So what do? We take 5 minus 3, that is what? That is 2. So we're going to use that pair. You have d squared. You have d squared. Let me use 5 plus 5d minus 3d minus 15. So now you're grouping them. D squared plus 5d plus minus 3d minus 15. Taking out common factors, which is d, and d plus 5. This side is minus 3, and d plus 5. Taking out common factors again, and you have d minus 3. Then, of course, remember your zeros this side. Then here you'll have d plus 5 equals to 0, or d minus 3 equals to 0. D equals minus 5, d equals 3. And then you're done. And then you're done solving these problems, guys. Thank you. This is the longest video I've recorded so far. But overall, I just hope all this helps. Of course, with a little bit of what's going to be done in chapter 2 and a little bit more of what is done in chapter 1. Make sure you do more practice. If you don't understand, rewatch the videos and cool stuff. And you can even ask me some questions in the comment section.